this is 487 from Blue Book, and it's not easy to find this sum. That's why we are going to have here, firstly we need to understand that one. We are going to name this one 1 minus I over root 2 as z, and I'm going to try to find the squares of them. Then cubic, I'm going to continue to that one, and I'm going to try to find 1 sequence with that one. If I say z is equal to 1 minus I over root 2, then z square, which is the second one, if this is z square, it's going to be plus this is z cube, and it continues like that. Then z square is equal to 1 minus I over root 2 square, root 2 square, and that's equal to numerator square over denominator square. That's why it's going to be equal to, directly I'm getting the square of it, 1 squared minus 2i plus I squared. It's going to be all over root 2 squared is equal to 2, which is equal to 1 minus 2i plus I squared. I squared is equal to minus 1. 1 minus 1 is equal to 0, so it's equal to 1 minus 1 is equal to 0. It's equal to minus 2i. The sum is equal to minus 2i all over 2, and here this one and this one, if you simplify the answer, it's going to be equal to minus I. So the first one, if it's equal to z, the second one is equal to minus I. And I cannot calculate the z cube because I know that it's not going to be a simple number like I or z, because the z cube is equal to z squared times z, and this z square, okay, it's simple number, but z is not simple number. That's why z cube, it's not going to be simple number. That's why instead of that one, I'm going to use, instead of z cube, instead of z square, I'm going to directly use minus I. So minus I times z, it's going to be z cube is equal to z, minus I minus z times I, it's going to be. What about z to the power of 4? Z to the power of 4, it's going to be equal to z square to the power of 2, which is equal to minus I square. It's going to be minus I square, it's going to be, and that's equal to I square, it's going to be. And I'm going to leave this one as I squared because I'm not going to find that's equal to minus 1. I'm not going to write that one because, as I told you, I want to see the sequence. What is the sequence? Okay, this is I squared. What is z to the power of 5? Z to the power of 5 is equal to, z to the power of 5 is equal to z to the power of 4 times z, which is equal to I squared times z, it's going to be, and z to the power of 6 is equal to z to the power of 3, or z to the power of 2 to the power of, here it's going to be equal to z to the power of 2 to the power of 3, which is equal to minus I to the power of 3. That's equal to minus I, that's equal to minus I cube. And if z to the power of 6 is equal to minus I cube, we are understanding that z to the power of 7, the next term, it's going to be z to the power of 7 is equal to z to the power of 6 times z, which is equal to minus I cube times z. Then I'm going to rewrite like this, z minus z I cube. And it's going to continue like this. And I'm writing here, what is the sum s? S is equal to z plus z plus z square plus z cube plus z4 plus, and it's going to continue like this. I'm going to write z6, z7 also, plus z to the power of 1997 it's going to be. Then z is equal to, the first one is z, the z square is equal to, I found it's equal to minus I, so it's equal to minus I. The third one, it's equal to minus zi, z cube is equal to minus zi. Then the fourth one, it's going to be equal to z to the power of 4 is equal to I square plus I square, and the z5 is equal to I squared times z, I squared times z, or z times I squared, whatever, it is same. and minus I cube. This is z to the power of 6 minus I cube, and the last one is going to be equal to minus zi to the power of 3. It's going to be, as you see, there is an order here: minus I minus zi, I square plus zi square. This is plus, this is plus, this is minus, and it's going to continue like this. If we continue in this form, it's going to be equal to minus, because the last term it's equal to, I'm going to write here. Now I'm going to find the last terms, which is equal to, which are equal to 1 minus I over root 2 to the power of 1996, or it's going to be equal to z to the power of 1996, and as you see, the terms z square here all be related with z square, z to the power of 4, z to the power of 6, z square to the power of 2, z square to the power of 3. So this term is going to be equal to z square to the power of 1998. It's going to be, okay, this means it's equal to z square. I found it's equal to minus y minus I to the power of 998. So it's equal to I to the power of 998. It's going to be the last term, 1 minus I over root 2 to the power of 1997. It's equal to z to the power of 1996 times z, which is equal to I 998 times z. It's going to be, or z times I 998. It's going to be. So I'm writing the last terms here, and when the powers are odd, was negative. When the powers are even, it's going to be here 998 even power. It's going to be plus. So the last two terms I'm going to write with plus. I to the power of, instead of 1996, I'm writing I to the power of 998, and instead of I to the power 1 minus I over root 2 to the power of 1998, I'm going to write z times I to the power of 998. I'm sorry. Okay, then as you see, 2 by 2, if we can group the terms, but instead of that one, I'm going to collect the terms with z together and other terms together. So I'm writing like this: z minus I plus I square plus, minus I cube, and minus I cube, and the last term it's going to continue with plus I. For when the power is odd, it is plus. When the power is odd, it is negative. When the power is even, it's going to be positive. So this is positive. The next one, it's going to be negative. I to the power of minus 5. It's going to be minus I to the power of 5, and it's going to continue like this till here. It should be minus. I said minus, but I wrote plus, minus, and then it's going to continue. The last one is going to be equal to I to the power of 998. The other terms here with z, all they are going to be written with minus. I'm going to start with minus zi. Then I didn't take this one because these two, they are related. This part is important. These two, they are related. These two, they are related. So that's why I got only zi, then zi square, then plus zi square, then minus zi cube, like the same order here. The next one is going to be plus again, plus zi4, then zi4, then minus, it's going to be, and it's going to continue. Then the last one, it's going to be zi to the power of 998 it must be. Then, as I told you, I'm going to group these terms, z plus. If you write it in plus, the signs are going to be same. That's why I'm going to get like this, minus I and plus I square minus I cube plus I to the power of 4 and minus, it's going to continue like this, plus I to the power of 998. And if I get z parentheses here, but this should be made plus z parentheses, it's going to be equal to, in z parentheses, z times minus I plus I square minus I cube plus I4 minus, and then it's going to end with the I to the power of 998. After this step, I want to explain something here. That's why I'm going to go down, because there is no place here, there is no space here. I'm going to go a bit down and I'm going to explain the things here. Here I choose this 4 consciously because this 4 it's going to give us 0, and I'm going to try to explain how it is. You know that here it's going to be equal to minus, here I'm going to write minus I is equal to minus I, then I squared is equal to minus 1, then minus I cube it's equal to here minus I cube it's equal to minus I times I square. Normally it's equal to minus I cube, so you will get the terms also here. It's equal to plus I, and the last one I to the power of 4, which is equal to I to the power of 4, it's going to be equal to 1. The sum of these 4, the sum is equal to 0. So sum is equal to 0. If I continue like this, I to the power of 5, I'm going to see that it's equal to I to the power of 4 times I to the power of 4 times I minus I. It's going to be equal to minus I to the power of 5, because the next term here I said minus I to the power of 5. So minus I times I to the power of 4, that's equal to minus I to the power of 5 minus I times 1, it's equal to minus I. And I to the power of 6 is equal to I to the power of 6 is equal to minus 1. It's going to be a bit up here. And then I to the power of 7 is equal to plus I, and I to the power of 8 is going to be equal to 1. Again, the sum is equal to 0 here. So all groups divided so in every 4 I'm getting 0, and I'm going to start to count from here. I to the power of 4, I 1 square cube 4 5 6 7 8 0 9 10 11 12 0. So the number, when it is divisible by 4, it's the sum of the group last 4 terms. It's going to be equal to 0. So this is equal to 0, and it's going to continue like this. Here also it's going to be equal to 0. Only the last terms, I think it's going to be like this here. If I rewrite this part, it's equal to z plus 0 plus 0. It will continue like this, 0 till the I to the power of 996, because this is the last term. After 997 and 998 we have 996 till 996 is going to be equal to 0. This number 996 divisible by 4, because 4 divides, here I'm going to write 4 divides 996, that's why it's going to end there. Then I to the power of 997 it's going to come, then this is going to be minus, this term is going to be minus here, it's equal to minus the last one, it's going to be plus I to the power of 998 8. Actually, as you understand from the group, if it is 996 is equal to 1, the last term, it continues like this. The order also minus I minus 1 plus I 1 minus I minus 1 plus I 1. So the order is also same. That's why these are going to be equal to the last two. Also, it's going to be equal to here. This is like minus I to the power of 5, which is equal to minus I, and this one it's going to be equal to I to the power of 998 is equal to like I to the power of 6, and it's equal to minus 1. It's going to be here. It's going to be equal to minus 1. And I'm going to, if I come to this step here, plus z times everything is same, 0 plus 0 plus, it's going to continue till end, and at the end again we are going to have minus I to the power of 998 plus I to the power of 997 and then 998, and they are going to be, this one it's going to be equal to minus I, and this one it's going to be equal to minus 1. So the expression is going to be equal to z plus whole zeros is equal to 0 minus I minus 1 plus z times whole 0 minus I minus 1. It's equal to z plus minus 0 plus 0 it's going to be, but we are not going to write minus I minus 1. Z times 0 is equal to 0 plus 0. Z times minus I is equal to minus I minus zi. Z times minus 1 it's going to be equal to here it's going to be equal to minus z. So the term it's going to written this one and this one we are going to simplify. Then the term it's going to be like this: z minus y, pardon, minus I minus 1 and minus z times I. Here I can write like this instead of z. Now this is the end of the question, that's why I can write instead of z what it is. Here I'm going to get a bit closer because I don't have space here. Then this one a bit up. Okay, then I'm going to continue. Minus I minus 1 minus z I is going to be equal to minus I minus 1 minus z is equal to 1 minus I over root 2 times I. Here it's going to be equal to, let me continue from this side and I'm going to continue to write then down. I will continue minus I minus 1 minus minus sign I'm going to take minus sign minus I times minus 1, which is equal to minus I minus I minus I square, it's equal to plus 1 all over root 2, and I times I is equal to I square is equal to minus 1 minus minus 1, it's going to be plus 1. Then I'm going to write here this root 2 as a denominator, because it says that in the question it says calculate the sum. At the end I'm going to find one complex number here. The sum it's going to be equal to here like here it's going to be like, sorry to wait you like this, root 2 minus 2 root 2 I minus root 2 minus I minus 1 all over root 2 is going to be. Then here I'm going to collect the terms with I together, without I together, minus 1 minus root 2 and minus 1 plus root 2 in parentheses I all over root 2 is the sum of the all these terms. It's going to be This is the answer of the question.